All right, so I'm ready now. So according to Lillian, we do it like we did yesterday. So we're going to try that. And by that, she means multiply. We're on 5b, the records. So plus y equals to t. And the second equation, 5 minus 2t x plus ty equals to 4. So Lillian is proposing we do exactly what we did yesterday, multiply by t and multiply by nothing. So I just put 1. And the implication of that is this. So this is going to be t bracket t plus 2 x ty equals t squared. And this remains 5 minus 2t x plus ty equals to 4. Then we subtract. Yes, Lillian? So we subtract, you get t plus 2 minus 5 minus 2t, everything x equals to t squared minus 4. Am I right? Yes? Okay. Do you guys get what we're doing so far? Good. So exactly what the questions say is when it has a unique solution, right? So Lillian, what do we do from here?
And then you can expand the things inside the bracket first, or just divide them over.
Okay. So if I do that, so I'm going to be getting t squared plus 2t minus 5 plus 2t. Yes? T squared minus 4. So this is simply t squared plus 4t minus 5x t squared minus 4. So on the other side now, so x equals t squared plus 4t minus 5, and at the top, t squared minus 4. Yeah, so this is x. So what do we do from here? Lillian?
And then if it's if there's a solution, then the fraction is defined, so the denominator won't be 0.
So
and then we solve.
Good. So if there exists a unique solution, then t squared plus 4t minus 5 cannot be 0. Yes? And it means, so basically you have to solve opposite of equals to 0, basically. So that will be t minus 1, t plus 5. Am I right? To be 0. If this product cannot be 0, then it means both not either. Okay, both t minus 1 is not 0 and not or this time. I don't need the word both, I'm just trying to explain. Okay, does everybody get that? If this product is not 0, it implies that t minus 1 is not 0 and t plus 5 is not 0. Because if you use the word or, it means it could be. So if I say t minus 1 is not 0 or, so when this is not 0, this could be 0. But if I use and, it means both of them can never be. Okay? So with this, it means t is not 1 and t is never negative 5, not 5. Is that what you got, Lillian? Okay. Guys, any questions? Anybody got this? Okay. Yeah, that's it. No, okay, let's see. Find the parameter T for which it has unique solution. Yes. Then another thing is, so there are two parts of the question. This is the part, find the parameter T for which we have a unique solution. Okay. So now, find the unique solution. Remember, it says when you have a unique solution, T cannot be 1 and T cannot be -5. This is when you have a unique solution. So T cannot be 1. Every other number except 1 and -5 gives a unique solution. So, and there are a lot of them. That is why you are asked to find the solution in terms of T. Does it make sense now? And you have just found one of them. That is your X. Okay? So all you have to do is get your Y. Can someone else explain the best way to get Y? Anyone? Quickly. I'm waiting, guys. Hello? Substitute the right-hand side. Yeah, I've said something about that substitute. Look, imagine substituting this complex fraction, this complex-looking fraction, into here. That's a lot. Okay, that's a lot. So what else can we do instead of substitute? I advise against substitute and we agreed on something. Does anyone remember? One of the solutions for X. Yeah, you are saying the same thing. Okay, into the first line, one of the solutions for X. I'm not getting what you're saying really, but that's not. Cancel X instead. Yes, we cancel X instead. What you did here was to cancel Y. Okay, so here you eliminated Y. What you did here was to eliminate Y. By eliminating Y, you get X. So if you eliminate X, you can get Y. So you just go back to your original problem and try to eliminate Y. Eliminate X, sorry. And to eliminate X, we multiply equation 1 by what? Somebody. And equation 2 by what? I'm waiting.
Equation 1 by 5 minus 2t, and the second equation by bracket t plus 2.
Perfect. That's it. So we can do that. So let's go to another slide. So I go back to the original problem. So to get my Y now, I go back to the original problem, which is t plus 2 bracket x then plus y equals to t and 5 minus 2t bracket x plus ty, it equals to 4. Okay, so this time around, we can multiply by 5 minus, where does this come from? Can multiply, sorry, just a minute. Okay, I multiply by 5 minus, no, that's not minus. 5, uh-oh. When I write 2i up there, it feels like I'm trying to drag the screen, so it drags it. So we multiply by bracket 5 minus 2t, and here you multiply by t plus 2. The idea is to have the same coefficient. Does that make sense, guys? So if you do that, we're going to be getting, to do that, we're going to be getting t plus 2, 5 minus 2t, x. Then 5 minus 2t, y. Then t 5 minus 2t. And the second one, so that is 5 minus 2t, t plus 2, x. Then t plus 2, y equals 4t plus 2. Does that make sense, everyone? So if we subtract, so if I subtract, this is gone. Okay. And with that, I can write this better. So that is going to be, I move to this side because of the space needed. 5 minus 2t minus t plus 2, everything times y, was t 5 minus 2t minus 4t plus 2. Does this make sense? Someone messaging me on WeChat from the class? No, okay. Not from you guys. Okay. All right, so let's open the brackets. Please let me know if it's okay or not. Please type in understood or not, so I know that everyone is following. So this is t squared minus 2t. So this, we also open the bracket here, 5t minus 2t squared plus 4 minus 4t minus 8. Okay. So is there a way we could simplify this? Yes. So I can say 5 minus 4t minus t squared into y. And here, negative 2t squared plus t minus 8. So y will be negative 2t squared plus t minus 8 divided by 5 minus 4t minus t squared. Something like that. Although we can factorize the denominator, but I don't think we can factorize numerator. You need to check that. Okay? Your numerator, remember, can somebody tell me when a quadratic expression is factorizable? I've mentioned it before in the class. When is a quadratic expression factorizable? Anyone? Karen? Can I ask you to tell me that? Hey, Miss K, are you there? Hello. Okay. Oh, it's all right, Lillian. Yeah, when discriminant is a perfect square. That's okay, Lillian. Thank you. Karen, is that understood? All right, everyone, do you understand that? So your quadratic, please speak to the camera so that, because I'm just reading your chat and your chat does not reflect in the recording, so it might not be a comprehensive message when you guys are trying to watch this later. So if you're answering questions, try as much as possible to speak to the camera, okay? Even if your background is kind of noisy to you, just try and let us be the one to say, oh, your background is so noisy. We might just get the message, please. So when b squared minus 4ac gives a perfect square, for the numerator, your b squared minus 4ac is this. B squared minus 4ac for your numerator is 1 squared minus 4 minus 2 minus 8. So this is 1, this is negative, and this is a very huge number. So this will be less than 0. So your numerator cannot be factorized. If your numerator cannot be factorized, then don't bother. I know the numerator can be factorized. And how do I know that? Is the opposite, like the negation of this one. Is the negation of this one. Okay, is the negation of this one, of this expression actually. Okay, so that's that. Any questions? So we can actually leave this here. So the solution, all you can just do now is to write a conclusion. Okay. It says find the solution in terms of t. So therefore, x equals, so let's go back to the previous slide. Can you see that? X equals t squared minus 4 divided by t squared plus 4t minus 5, and y equals minus 2t squared plus t minus 8 divided by 5 minus 4t minus t squared. That will be the solution in terms of t. Understood? Okay. Mr. Chen, the question is sorted. All right. Any other question from yesterday? All right. So, today, yesterday also we started the row operation. So please go to page 2 of the worksheet that I sent to you. Did anyone try any of the questions, 11, 12, blah, blah, blah? Did anyone try it? Okay, so about question 11, did you try 11, anyone? Okay, who did not try 11? Whether you didn't have time or you couldn't get it? Okay, is that yes, you tried it, or yes, you couldn't try it? Sometimes it's confusing if I didn't hear you. Tried it, okay, try, good. I got a response from about 4 people. What happened to the rest of us? Okay, just want to be sure. All right, great. Please respond. So is there anyone you wish we could do together? Anyone? You guys wish we could do together from this 112, Krista, really? That's 112. Come on. Okay, 11C. Oh, 12C, 11C. So which one do we take now? There's no 11C. Look at the question on your screen. I have 11A and B. There's no 11C. Or do you mean 12C? Yesterday's question. I don't have yesterday's question, Krista. If you could take a picture, if I've changed the number, okay, it's 13C now. All right, okay. Okay, so everyone, let's try. Not 13, I didn't try. What do you mean not 13? Like you don't want us to try 13? Or you're just telling us now that you didn't try? 13C and 14C, I think, because you didn't assign. Yes, I didn't assign, I just asked us to try. But that's okay. But even if I didn't assign you, if you have time, just make attempts. The more practice you do, the better. So question 11 from yesterday is now question 13. Okay, so let's focus on question 13, everybody. So question 13, as you can see, says consider the system of linear equation where this So let's see. Write the system as augmented matrix. So let's go back to the board. Maybe I write this on paper so I don't have to open mine. Or can somebody call the question for me so I don't have to open through different? Anyone? I have minus 2x. Somebody help? Minus 2x minus y equals 5. What's the second one? Hello, come on. Is everyone having problem with their mic? Guys, come on, I don't like this anymore.
I think the first one is 2x minus y, not minus 2x.
Thank you, Brandon. Guys, seriously, we need to turn on our mic. We need to. I want this to be a two-way communication and I get frustrated if it is not. We need to. Now I don't care if you have construction going on behind. We need to. I need to hear from you. Thank you. Okay, so the first question says, write it as augmented matrix. So what would that be? Yeah, let me hear you. As augmented matrix, this will be, we have a 2 by 2 first, 2 minus 1 minus 1a. And here will be 5, 3. Yes. The next thing is multiply the second row by negative 2. So if you multiply the second row by negative 2, so this will become, you can put the description of what you did here or here, like I said yesterday, but I just like it on this side. So I'm going to use the other side now. So 2 minus 1. So if you multiply by negative 2, you get 2 and negative 2a. And this is 5 and this is 3. No, 6.
Negative.
Negative. Thank you, Brandon. Thank you. Negative. Okay, so the last question is, for what value of A is the equation inconsistent? The first question is, what does inconsistent mean?
When there are no solutions.
Good. When we say when there are no solutions, in this case, what is that thing that you see that makes you know there are no solutions?
For x, the value is both 2, but the answer on the right-hand side is 5 and negative 6.
Can you say that again?
The x value is 2 for both equations,
Value
but
of coefficients.
The coefficient.
Okay.
And on the right-hand side, the on the first equation it's 5, but on the bottom one it's 6.
But that does not tell us that it means there are no solution.
On but no.
Are you getting my question? The fact that the coefficient of x on both are the same and on the other side is not, does not mean there are no solution. I'll give you an example. Look at x plus y is equal to 2 and look at x minus y is equal to, if this is 3 and this is -1, is equal to 4. There is a solution here. Because if you subtract, this will be 2y equals -2, and y is -1. And if you add, on the other hand, if you add, you get 2x is equal to 6 and x is equal to 3. So even if the coefficient of x is the same here and the solution, the constant in the solution is not the same, you can still have solution. Do you understand my point?
Yep.
So that is, so what is the criteria for not having solution? Yes, yes, Lillian.
Yes, yesterday you said try to make the bottom row 0, right?
Mm-hmm.
And then so like since you have two 2's in that front place, then you can take row 2 minus row 1, so the bottom, like the first coefficient for row 2 will be 0.
Mm-hmm.
And then the second coefficient will be -2a minus 1, which is +1.
Mm-hmm.
And then the third, like the coefficient of the answer would be
-11.
Yeah, -11. And then but yesterday you also said we can write this back as equation form. So we write in equation form, this would become -2a plus 1y equals
So
-6.
A plus 1y equals -6. No, -11.
No, -11.
Okay. Mm-hmm.
And then, but how do I explain this? If the coefficient of y is 0, then there's no way that 0y will become -11. So there will be no solution.
So there will be no solution if this is 0. If -2a plus 1 is 0. Is that what you mean?
Yeah.
Does everybody get what she's trying to say? Guys, okay. Okay, so Lillian, rather than go to this, do you agree this is the same as that? Yes?
Yes.
So you can actually look at it from here. Can you see that? So if there is no solution, it means you will have the same coefficient for x and y on both equations. Does that make sense?
Yes.
So you already have yours x solved, 2, 2, right? So for the y, they must also be identical. Even if this side is not, we don't care about that. But this will be identical. So if they are, it means, so if there exists no solution, then -2a must be the same as -1. Then a will be 1/2. That's it. So you don't have to do the row operation, actually. That's why the question, this set of questions for now, they are guided questions. So they are not really asking you to go through the stress so far for now. Does that make sense, everyone? So if there is no solution, it means the coefficient of x and y in both equations are the same, such that if you decide to subtract, you get nothing. Okay, so that's why we have that. Any question? No questions or yes question? So that's that about 13, okay? And you can maybe try others also later. And let's see if you have questions, you can bring it later. So we're gonna be looking at the 2x2 ones. Look at section C of the worksheet. So we're looking at the 2x2. But first of all, let's discuss consistent, inconsistent, blah, blah, blah in our row operation. If you have your textbook, I will have refer you to a particular page, but you do not have it, so I'll just explain it. So let's first write, Yeah. So maybe in your notebook, so just write solving 2 by 2 linear system. Solving 2 by 2 system of linear equation. Yeah. So basically, you can have 3 cases. So far, we've talked about either you have a unique solution when you have any form of equation, be it 2 by 2, 3 by 3, or any order. You can have no solution, you can have unique solution, you can have infinitely many solutions. Now, when you have no solution, it means it is inconsistent. Let's say, so far. So I put it this way, so far. Or should I say possible cases? So these are the possible cases to encounter, all right? So we can encounter the case where it is consistent. When it is consistent, it means there are solutions. So if there are solutions, you might have unique solution. You can have infinitely many solutions. So another case you might encounter is when it is inconsistent system. Inconsistent. Please tell me if there's a typo. So for consistent system, which means there is solution, there is at least one solution. So the solution might be unique or it is infinitely many. For inconsistent set of equation, it means there is no solution. So this is when there is no solution. There exists no solution. So this is everything you might encounter. So as a result, what would our row operation look like? Now, I've told you, the idea of row operation is to go from maybe A, B, C, D, maybe MN, and to reduce it until you get something like PQ, 0R, and maybe by then this will have been after a series of operations, all right? And this will be perhaps EF, something like that. That is the idea, such that in equation form, this is actually Px plus Qy equals E if X and Y are the variables, and this is just Ry is equal to F. Then you can get your Y and you do backward substitution. So if your Y is F over R, then you do backward substitution. Okay, so this is the idea of row operation. So in this case, this is actually consistent with the case of unique solution. Okay, now what are the other cases you might encounter? How does our row operation look like when trying to solve a 2 by 2 linear system? So let's go to the next. Can I take it to the next slide, whiteboard slide? Okay, wait. Okay, somebody said wait. All right, let's give Brandy a minute, 10 sec. Okay, thank you, sir. Okay, thank you, sir. So there are possibilities. Format, maybe I call it forms of, possible forms of possible cases in row operation. So the first one, for unique solution. When it says unique solution, that is one. Okay? Unique. I'm considering this thing, okay? For the consistent, we have one. So this is one, case one. This is the second case we'll discuss, and this is the third case we'll discuss. All right? So for the first case, unique solution. So after your row operation, if you have a unique solution, you will get the form this. There is something here, there is something here, there is something here. Usually this will probably be one. The idea is to actually make that one. So there will be some number here we don't know, 0, there will be maybe 1 here, and something here, something here. Okay, so 0 will be here, there will be a number here, you try to reduce it to 1. It may not be 1. So for example, if you have 2x and if you have 2 and on the other side this is 4, nothing stops you from saying multiply this row by half. And when you do that operation again, then you get your something something, and this will be 1 now. Do you understand that? Can I get a yes? That's what it means by 1. Okay. Hello. All right, so I'm comparing it to this. So look at this now. We got RF, right? Rather than using the RF directly, the operation I could perform next is to say 1 over R times R2 is now my new R2. In that case, this will be ordinary 1, and this will be F over R. Then I can copy. So directly from this step, I can just conclude this. I don't have to go through this. That's what it's saying. Does that make sense? So don't panic that, oh my God, I'm going to get 1. Yes, you're going to have to get 1 by performing the last simple operation. Okay, all right. So the other one we might have is when you have, what is the second case? Infinitely many solutions. Can somebody remind me, when do we get infinitely many solutions?
When the equations are equivalent.
When the equations are?
Equivalent.
Equivalent. Overlap. Karen said overlap. So when they are equivalent. When you say overlap, Karen, there is a word for it. We'll get to that in a bit. So when so you have infinitely many solutions when the equations are all more or less the same, right? They are like equivalent to each other. So if one is 2x plus y equals 7, the other might be 6x plus 3y equals 21. Okay? And what you notice is that if you decide to do an operation, maybe let's see what happens here. I've just multiplied by 3, isn't it? So I want my second row to now be my initial second row, okay? My initial second row minus 3 times the first row. What do you notice, guys? This remains 2, this remains 1, this remains 7. Remember, this will be 2, 1, 7. Okay, maybe I make it look like a concrete example, but okay, we can actually figure it out here. So now I want to, my second row, I want to perform this row operation. Yes, what do we get? Last line. Yes, that's it. That's what you get. So in this case, Lillian said you're going to end up getting this. And that's the idea. Infinitely many solution is when you have the two equations are equivalent, like you said, which means you have one equation for two variables. So if you have one equation, it means the other does not exist. Does it make sense now? So again, we always try to make sure the first element here is 1 because it makes our backward substitution easier. That's the whole idea. So the format for infinitely many solution is going to be this. So if you are going to end up getting an infinitely many solution, your augmented matrix at the last step will look like this. There will be a 1 here. Okay, this will be 0. Of course, this could be any number. We don't care. This could be any number. We don't care. This will be 0 and this will be 0. So when you have this, okay, Leo, bye. So when you have this, it means you're going to end up getting infinitely many solutions. Does that make sense, everybody? All right, good. And the last case is when there is no solution. Can I ask you to try to give me, just like this one, what the augmented matrix will look like for you to know there is no solution? Now, this is the reason we are actually talking about this. When trying to perform your row operation, you will end up in any of these three forms. And you are either to proceed if there is a solution, or to say, oh, there is an infinitely many solution and give us the solution set in parametric form. Or if you have no solution, you should be able to identify there is no solution using looking at the augmented matrix that you have obtained after performing a series of some row operations. But how do you know, even if you don't know the format, what the format will look like? That's the point. So can I ask you to try the third one? I give you a minute or two. Think about the case where there is no solution. Okay, what will the augmented matrix look like? Think about when there is no solution in the problems you have done last class or maybe last two classes. What really happens? What are the conditions and what do you think this will look like? Send to WeChat, please. Then I might call on somebody to explain. So send to WeChat. I'm waiting. I'm waiting, guys. Okay. The results are coming in. Thank you, Crystal K and Lillian. Because 0y cannot equal to something, yes. So if there is no solution, like we discussed before, you are getting something like 0y equals maybe 4. And the coefficients of any of the variables cannot be 0. Okay? Remember, if this was maybe my, y will be equals to 4 over m. And there is no solution when this fraction does not exist. And this fraction does not exist when m is equal to 0. Okay? We've talked about that before. So the coefficients of the variable will be 0 if there is no solution. Okay? So this happens when coefficients of the variables, okay, are zeros. Okay. And in this case, we have the augmented matrix that looks like this. Of course, that could be anything. This could be anything. And this will be anything as well. Because the condition is not on the results, on the constant on the right-hand side. The condition is on what you have on the left-hand side. Can you see the difference? Okay. In this case, you have only 1 0 at the bottom. In this case, okay, you have only 1 0 at the bottom. In this case, you have 2 zeros at the bottom. In this case, you have 3 zeros at the bottom. Maybe I should have rearranged it in the other way, so it's easy for you to remember. 1 0, 2 zeros, and 3 zeros. Okay? You might want to rearrange it if you want. Okay? So here you have 1 0. Quick thing to remember. But you don't have to remember with the number of zeros. I'd rather you remember with the conditions. Okay? Remember with the conditions. Any question, please? This is it. All right, thank you very much. So these are the formats that you might end up you might encounter when trying to. So if you reduce your row operation and you get something like this, then you conclude there is no solution, okay? If you get this, then you know, oh, there are infinitely many solutions, and in parametric form, let x be t, then y will be something. Or let y be t, then x will be something in terms of t. And here you will get the exact solution. X is 4, y is 2, something like that. That the solution is unique. Any questions? Okay, thank you very much. So now, let's try to solve some problems. Maybe we go to the worksheet now. Basically, I would just want us to discuss 2 by 2 and wait. Are we 11 in the class? With Leo, 11? Yeah. Okay, so I'm going to now show you the worksheet again on my screen. Okay, so which one shall we do first? Maybe we consider 16. Let's consider 16, shall we? Together? Yeah? Okay. So let's consider 16 together. I can open it on my phone actually. All right. So according to question 16, it says consider the system of linear equations. I want you to please be part of this, so not just me talking. If I may just hang my phone. Of my studio. Now it's becoming a mass studio, guys. Okay. Yeah, sweet, nice. All right, so according to question 16, it says, consider the system of linear equations that, so this is the system. For x minus 6y, please don't start, is equal to -1, ax plus 2y equals 2, and it says A belongs to R. Okay, so we put it in augmented matrix. That's the first question. So if you write it as augmented matrix, so we have 4, -6, A, 2, -1, and 2. Okay, then the next thing is multiply the second row by -3. Second row by -3. All right. So multiply the second row by -3, you get, this remains what it is. Let's just follow the instruction. And the next question is, for what value of A is the system inconsistent? So who wants to answer that? This is actually the easiest of the question. So what do we do to say it is when it is inconsistent? The system is inconsistent if, yes, if what?
If A makes the coefficient of the bottom coefficient of x
Give me as an equation. The first thing is, what is inconsistent? I haven't heard from some people. Maybe I start taking note of your contribution. I haven't heard from Calista. I haven't heard from Clarissa. I haven't heard from, let me find the list of everybody. Yeah, I think those two especially. What's going on, Calista and Clarissa? I need your contribution, please. Yeah, there is no solution. Exactly. That's what inconsistent means, Karen. So how do we write it as an algebraic equation? Okay. Yeah, how do we write that? Yeah, Lillian. Okay, I just saw what you wrote now. Okay, thank you. So if 3a is equal to 4, that's it. Negative 3a, I mean, is equal to 4. And that implies when a is equal to negative 4 over 3. And that's all. Okay, for what value of values? So that is the only value. Okay. Any questions? All right, so let's look at 19. I pick one of the 19s. Use row operation to solve. Maybe I go for 19D, because my name is Daniel. Or maybe I do 19C for Clarissa. So, oh, who is C again? Oh, Krista C. Sorry, Krista K. All right, let's look at 19C. It says use row operations to solve the system 2x plus 3y equals negative 8, x plus 4y equals negative 9. So again, first thing is to put it in augmented matrix form. 2, 3, 1, 4, negative 8, negative 9. Okay, so the idea is to have it like this. To have it like this, or like this, or like this. That's the idea. Okay, so in any case, we want to make sure we have some ones, right? Okay, so what is the easiest thing to do? This already has 1. Remember, the possible things you can do in the row operation is to either interchange, yes, or what? Do you remember those 3 things you can do in the row operation? Guys, do you remember? Okay, I'll show you again. Swap. Yeah, of course, swap. So you can either interchange, you can change the row, you can multiply by non-zero, yes, and you can add multiple of non-zero, yes. So I hope you guys remember this from before. Yeah, here, remember this from yesterday. Can everybody see the screen? Can you see my book? Yeah, so looking at these 3, which of them do you think we can do first when it comes to this? Which of them do you think we should do first? Someone please. You can interchange, yes. Because 1 is already there, so there's no point wasting your time, right? Just interchange. So I'm going to say this is 1, 4, negative 9, 2, 3, and negative 8. And what you have done is row 1 is interchange with row 2. Okay? And of course, you can write it here if you want, but I think 1 is enough. okay? But you can write it right before it, okay? I forgot to write this one. I think row 2, -3 row 2 is now changed to row 2. Okay, don't forget that. Okay, so now back to that. We want to make sure this is 0. How do we make this 0? Yes, contribution, divide by 2, that doesn't make it 0. And you don't divide usually. You can multiply by half, but you don't really need that. Yes, Krista said multiply the first row by 2, then what? Yeah, Lillian said R2 minus 2R1. So again, let's go back to that instruction from the book. It says you can multiply any row by itself. Okay, you can replace any row by itself plus multiple of another row. Okay, replace any row by itself plus multiple of another row. So that's what Lillian is talking about here. Okay, so we're going to replace row 2 by itself plus a -2 multiple, kind of. The multiple of another row would be -2 times R1. Does that make sense? Can I get a yes if you understand? So basically, our row 2 so our row 2, yes, -2 row 1 is now row 2, something like that. So this gives this. So row 1 remains what it is. So row 2, the new one is going to be the old row 2, which is 2, minus 2 times row 1, which is 1, so you get 0 here. Okay, again, considering this one, the old row 2, which is 3, minus 2 times what? 4. Please tell me if I made a mistake. So this is -3. Any error? Did you see any error? Then you can have -8 minus 2 times -9. So that would be -8 plus 18. Is it? Which is 10. Is there an error? Can somebody check, please? Any error, please? Okay. Is that -5? Oh, sorry. So this is -5. Thank you. This is why I need you to respond. Thank you so much. So that should be -5. Maybe I didn't get enough sleep, according to what we discussed theory. Is that correct now? Okay, so now, if we want to make it these forms, remember the 3 forms that we talked about earlier. Okay, now it's looking like this, right? So what else can we do? We can actually multiply row 2, replace row 2, because according to the instruction I showed you now, you can replace any row by a non-zero multiple of itself. Okay, so I'm applying the second stuff now. So I can still do one operation, leaving this the way it is. So I can replace this with -1/5, replacing my row 2 now. Okay, so this is 0 and this is 1, and what is this? -2. Does that make sense? Okay, so with this, now it's easy. So if I'm to write it back as an equation, it's going to be y equals -2, correct? So that is exactly what we're talking about here. Rather than go through ry equals something, then you later divide, you can write it directly. So if I didn't perform the last operation, I'll probably say minus 5y equals 10. Of course, I will have to divide. So in normal way we do it is that from the last operation that you perform, you just make sure you have a 1 so that you can pick the answer directly. Now that you know your y, writing the second, this is a backward substitution now. Writing this line now, this line back is going to be x plus 4y is equal to negative 9. Now you see why that is 1. Can somebody tell me why it is necessary for that to be 1, looking at what you have here? What is the significance? I'm waiting, guys, quickly. So we can find x, yes. So we can get the direct answer, more or less. So there's no need to divide. Yes, exactly. You are all right. Okay, so you don't have to divide anything. So basically, x is negative 9 minus 4y. So it's easier because you don't have to divide anything. So that's negative 9 plus 8, which is negative 1. So our solution, x is equal to negative 1, y is equal to negative 2. Any questions? Okay, so I'm going to ask you to please try quickly. How about you do 4A? No, 19A, everybody. 19A. Shall we take 3 minutes, please? 3 minutes, 5 minutes max. You can copy this later. Just leave the space in your book. I'll leave it on the screen so you can use it as a guide. Or maybe I leave the, do you prefer I leave this on the screen or you prefer I leave the steps? Or maybe I can do both. I don't know if I can do both. You want to copy that first? My paper is different. No, I sent you the new paper today, Brandon. I sent you the new one. Yeah, I sent to the WeChat group about 3 minutes to the class, or 2 minutes to the class. It's the same paper from before, but I've added more questions, so it's more, there are more questions here. So when I send the last version, maybe tomorrow over the weekend, I will have added all the papers and maybe include some IB past papers as well. So it might be even be more comprehensive. This question 19 might be question 20 something by then. Because I'm going to arrange them according to the categories, particularly how we learn the principles. So I'm not just going to dump it like that. So I'm trying to group them into same stuff. So guys, is everything okay, or do you want me to project the textbook where the instructions about the operation is? I mean, do you want this on the screen, or do you want the board on the screen so you can follow through? Which one do you prefer? The board. Okay, so I leave the board. All right, thank you. Okay. Le gars de Ben. Yeah. Vale. Okay, messages coming in. Message received from Crystal. Checking now. It's quite easy, isn't it? Crystal, I didn't see your first step clearly. Oh, who's the first one? Yeah, the way you took your picture, I can't see your first step clearly, but I think you're right. Very good. Lillian, very good. Callista, why is Callista out of the room? Coming back. Very good. Nikita. Callista, got it. Good. Krista, I've sent you your new picture. Thanks. Message received from Ethan. Very good. Well done, guys. So that is correct. Krista C. Good. So can I ask you to look at B, 19B. Please attempt 19B similarly. And also attempt 19C. There will be no homework. So after any practice we do, any other thing you do is your self-practice, okay? Checking Clarissa's work now. Yeah, very good, correct. Very good. Vena, I'm checking your work now. Perfect. Very good, guys. Well done, everybody. I haven't got from Mr. B, from my favorite foodie. Who's my favorite foodie? Everybody knows. Raise your hand if you're my favorite foodie. So I haven't got from like 2 people, yes? So I have 1, 2, 3, 4, 5, 6, 7, 8. Leo is out of the class. He had to be somewhere. So I have 2 more people. Message received. Crystal, I got your B parts. Okay, Brandon, did you send me the first one? Because now I can receive your B, but the first thing was A. Can you respond to explain? Okay, next time send me A quickly before you start your B. And please look at that A properly. What you got in the second row is 003. With that, it means there is no solution. So how did you get 003? Let's check what you did. Karen, first one received now, or second one in progress. All right, good. Please make sure you send the first one before you begin the second one so I know and I can correct any mistake. Is that okay, Miss? Good. Okay, so everyone is okay with A. So I'm going to be looking at the B that you sent in now. Oh, Brandy's, okay, yeah, I've told him. So who is the first solution here? Okay, Lillian, let's see. You can attempt D while you wait. The operation is the last thing we'll just do. Good job, Lillian. Who is the next one? Krista K, checked, well done. Nakita, I'm checking now. Nakita, can you hear me? Okay, so the first thing you did was to, can you turn on your mic?
Yeah.
All right, so can you explain why you first negate your R2?
Oh, cause I wanna make it to 1, like just make it not -1.
Okay, so what you could do next time, this is a good idea. What you could do next time is to combine those two steps. So initially you did negation of the second row, right? Then later you did row 2 minus 2 row 1, right?
Yeah.
So next time what you could do is just combine the two steps by saying minus row 2 plus 2 row 1, or you do row 2 minus 2 row 1. Both of them will work.
Yeah, okay.
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 Two steps. Well done, but this is correct. Very, very correct. Okay. I go to the next person. Krista C. Crystal, are you there? Krista C. Okay, is your mic working? Okay, can you talk to me with the mic, please? I have some questions for you. Okay, so your augmented matrix is correct. So you got 1, 7, 2 minus 1, 17 minus 1. Then you change your row 2 by doing 7R2. May I know why? If you can walk me through what you did, then maybe I can chip in what is wrong.
I want to cancel 7.
You want to cancel 7? But remember, 7 is in row 1. We have no business with 7. your row 1 from the question is actually perfect because you have 1 as the coefficient of x, which is actually what we want. If you look at the board, is your board visible to you?
Yes.
So, can you see my cursor?
Mm-hmm.
Did you see this?
Mm-hmm.
So you already have 1 and you have a 4 here. Remember, we never targeted this 4 and tried to cancel this 4. We left it because it looks like what we want already. What do we want? Come with me to this slide. This is what we want. We want 1 here. We want some number here. Nobody cares what this number is. Do you understand that? We want 1 here, we want some number here, and that's all we need. And that we have here, which is why we never bothered. Our focus should be on this row. If you have 1 here, nobody cares what is here, your focus should be on the other row. Do you understand that?
Yes.
Can you look at it again? And if you still can't do it, then I'm happy to walk you through the solution, but I want you to make an attempt again yourself. Okay?
Okay.
All right. All right, someone is sending a chat, I guess. Okay. For now, somebody sent me a message that they want to go if we have nothing else to do. I was going to discuss this 22, but I don't think we have enough time because I want people to actually practice what we're doing. So maybe on your own, you can attempt it. If you are not able to, it's not assigned work. If I could use that language Leo used. So it's not assigned work. You can attempt it. So we could start from here tomorrow before we move to 3 by 3. So you can also attempt, you've done all the 4 here. We have done C together. You've done up to D. You can consider the other questions, all this K stuff. Oh, I'm not showing you the... So again, while I'm waiting for others to complete their work, so this is where we will stop, okay? So for those that want to leave, somebody just message me now. So you can attempt some of this on your own, but this is the one I was going to discuss with everybody, question 22A. Then maybe you can do 22B, but you can try it on your own. This is also one of the questions that would be interesting for us to look into. I mean, question 23. Okay, that will also be another interesting question for us to look into. So you're welcome to look at them on your own and just do more of row operations so that you are used to the skills. That's the main idea here. These are guided parts because they told you already replace second row with blah, blah, blah. They are guided questions, but these are not guided questions. That's why I wanted you to try this especially. So also try this, explain why there are infinitely many solutions. I want you to make an attempt and try to solve, then also try something like this, just try it. And as many as you can under the 2 by 2 system of linear equations section. Okay, so if anyone, somebody just complained of headache now and that she needs to leave, so please, you are welcome to leave if you need to rest. Okay, while the rest are practicing the last question, please send me your remark before you go. Okay, thank you very much. So bye to whoever that is leaving now. And we'll see you tomorrow. Take care of yourself. Make sure you get enough rest. Okay? Okay, bye. Okay, guys, so I'm checking now. So, Krista C, I'll be looking forward to the correction of what you did. So I'm checking for others now. 19B for Calista checked. Clarissa 19B checked for Clarissa, correct. 19B for Vena, checked, well done. Brandy, 19B, checked, correct, well done. C. We did D together, right? Oh, no. Brandy, you sent me C. I thought we did C together. So Crystal K, I'm looking at the D now. That's okay. So you interchange the role. Crystal K, your D, you just wrote interchange. No, don't use the word interchange. Put the description in terms of R1, R2, okay? Crystal, can you hear me? Hello?
Hello.
All right, so now look at D, where you wrote interchange. Can you see that?
Yeah.
Rather than writing interchange, write beside it on the specific row, okay, which is row 2 in this case, or maybe row 1 because both of them were interchanged. So write R2, change to R1 using that two-directional arrow. Okay, that's better notation.
Okay.
All right, thank you. So the rest of you, I'm checking now. Sorry, give me about 2-3 minutes. We'll be done. So where's the D again? Okay, all right. Maybe if I have double screen, it will be faster. Okay, so now I'm checking for Mr. Chang. Oh, this is B? What's happening? You're just doing the B? Anyway, that's correct. So on D now, okay, great, no problem. Callista, that's D question for Callista. Interchange also, good. And she did R1 minus R2. Callista, she's gone now. When you watch this video, R1 minus R2 goes to R1. So the direction is not complete. The description is not complete. Okay, I need to see R1 minus R2 is now replacing R what? Is it replacing R1 or replacing R2? But I think what you meant is replacing R1. Okay. You see, even though most of you use different operations on the row, you end up still getting the same result. Yeah. So correct. Good. Interchange R1 minus R2. Very good. I've seen Venus' note and I've seen Nakita's note. Well done. But both of you did D, and one of you got X is 2 and Y is -3. Nakita, do you want to check? Because most people got x is 4. What's going on? Okay, someone else got x is equal to 2 also. Who is this? Let's see. We might have to do it together if we are getting conflicting results. Lillian got x is equal to 2 as well. Others are getting 4 as x, but y remains minus 3. So what exactly is the problem? Okay, now we have divided stuff. Some got x is 2, some got x is 4. So we need to do the correction and see what is actually wrong. Okay. So shall we look at the question again to be sure what is wrong? I did something, no, it's me. Okay, so it's not just you. I think some other people also. Oh God, so if you got the same result as Vena's result, you might want to look at it again. She's acknowledging she did something wrong. So maybe others can check also. I redid it too. Okay. So which answer did you guys get that you need to do? Is that for the case of x is 4, the case of x is 2? The people doing the correction, please respond. Okay, redo x is equal to 4. So you mean x is 2 is correct? Okay. So if x is 2 is correct, then the likes of, yeah, I think so. Okay. All right, the answer is x is 2. Okay, thank you very much for that. So if you have gotten x is 2, relax your mind. So they are fixing it. All right, so with that, I think we can stop. So thank you so much, guys, for coming again today. And we'll see you tomorrow for the last session of the week. And I'll talk to you on WeChat if we need to fix our schedule again based on the opinion that I've received. You know, it's always good to have you guys chip in. Yeah, wait quickly. All right, Ethan, I'll wait. So let me release the class so we can discuss our EE stuff. Any question from anybody? Anyone? Questions? No? All right, so just say bye to everybody in the chat and you can take your leave. Thank you. You can take your leave. See you tomorrow. Take care to get enough sleep. Thank you. Karen, are you there? She's gone. Okay, Mr. Chang, so I'm gonna switch this recording off, then you and I can talk.
Can I screen share?
Hold on, please.